my curve, am I right? This is my curve, which is that equation, 2x squared minus x minus 1. So everybody stop writing, just listen, because I want you to have this understanding. This is very important that you have to understand, so you can apply. The calculus is about understanding. If you really understand it, you can apply. Okay, it's not like a college algebra. College algebra, you have no idea what you're doing, just doing same thing over and over, right? Calculus, you gotta have understanding. So we have this area, we have this curve which is called 2x squared minus x minus 1. Then we're only looking at from the area between what? 2 to 5, 2 to 5, right? And then it says draw how many rectangles? 6 of them. All right. If I draw more rectangle, can I estimate better? Like for example, if I decide to make my rectangle twice more, 12 of them. So I'm drawing another rectangle right here. Are you with me, class? So now, class, I have how many rectangles? I have 1, 2, 3, 4. Does everybody see it? I got more rectangles now. Okay, now tell me, which one is more accurate? The new rectangle there, which estimate is better? When you have n equal to 6 rectangles, or n equal to 12 rectangles?
12.
Which one is better estimate? 12. Why? Now, I got more area covered. Remember this part that you didn't have before? Now I have a what? I have it here. Do everybody see that? So now only thing I didn't cover is what? That white part. Is everybody with me? Okay, what happens if I draw even more? Hey, now I want to make n equal to even more. 24. All right, so which means I'm cutting in half again. Are you with me, class? Are you following me, class? You know what I'm doing right now? Okay, what happened to my area now? Can I estimate it better with having a more rectangle? Do you agree?
Yes.
Okay. So I want you just to see this. Look at class. My 24 rectangles now pretty much cover every part of what? My curve. Only thing is missing is which part? Only just tiny bit over here is what? Missing. So my estimate is what? Getting better and better and better. So if I have, this is also, by the way, I can rewrite this as a summation, right? Remember the first rectangle, okay, first rectangle, you're gonna say rectangle 1, you're gonna say, okay, f of x1 times what? Delta x, right? So this little thing right here is delta x. So delta x is my what? Width. Am I right? And then f of xi is my what? Height of my rectangle. Is everybody with me? So if I want to, I can write it as 1 like this. For this case, how many rectangles you have? 1, 2, 3, 4, 5, 6. I can say 1 to what? 6. And f of what? Xi and delta xi. That's what that means. That's my area. Are you with me, class? Because you remember we learned this mean means what? Summation. Remember your homework? You have to make your 6 rectangles. How did you do? I found the first one plus what? I found the second one plus dot, dot, dot. How many did you do? 6 of them. Am I right? I can just write it like this. All right? So today's lesson is all about this. So you all agree, if I have a more rectangles, they give you a better estimate. Am I right? So today I'm gonna do like this. If I do limit, I'll put this to be n. If I limit, the n goes to infinity, which means what? My rectangle gets so small, almost like a stick. Can I cover everything under the curve then? Theoretically, yes, right? Am I right? Because my rectangle is so thin, I can just draw a line that covers what? Every bit of my area under the curve. That's the concept. I'm gonna say, hey, let's make my rectangle to be so many, infinitely many, that will cover every bit of this curve. Then my area would be what? So accurate, so close to the true area. Because right now, you see this is not true area. This is way too big. If I do this way, what happens? Class, if I do area, or if I only use 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, 6 rectangles, okay? The area estimation is not that good. Everybody agree? This part is not calculated, that is not calculated, that is not, that is not, that is not, that. There's so many of them is not calculated. If I do this way, what happens? I overestimated this much. That all those are what? Should not be part of the area, because area under the curve should be what? Only under the curve, not above the curve. So this area is all false. Those are all wrong. Is everybody with me? So this is overestimation. What is this one? Underestimation. But can I make it better? Yes. How? Making my rectangle what? Many, 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 right? My width to be what? Tiny. Right now my width is almost half. This is half, that's half, that's half. But how about I make it to be quarter? Next time I make it to be what? 1/8, 1/16. What about 1 millionth? You understand? My height gets what? Same, but my height depends on this. But my width is what? Getting smaller and smaller and smaller. Are you following me? That's the concept today I'm going to talk about. Okay, so let's look at the lesson 3. So class, this is what I'm trying to say. You don't have to do all this calculation because I just want you to understand. So we're going to understand the definition of Riemann sum. That's what I was trying to explain to you, the homework problem. That's the Riemann sum, okay? Evaluate definite integral using limits and geometric formula, and evaluate definite integral using properties of definite integrals. I cannot say properties, okay, properties. Riemann sums. This is what we're talking about. How about I change my sum to be what? My rectangle to be smaller and smaller, smaller, then I get what? Better estimates. This is what it's talking about. If I make n means my upper limit. Are you with me? How many rectangles you're gonna have? If I make my rectangle to be what? Infinitely many, then my area will be what? Very, very accurate. So we're gonna use, this is a definition of a Riemann sum, using a limit. Saying, hey, let's make infinitely many rectangles. Then I can estimate my area to be what? Very, very accurate. That's what that means. So don't worry about all this. That's the one we just did, so don't worry about all that. But does everybody understand about the n goes to infinity, why we're doing that? Is everybody with me? Does everybody understand why we're using n goes to infinity? The concept is, I'm making my rectangle to be so thin that will touch every part of what? Curve. Okay, let's go to this one. So definition of a Riemann sum. Let F be defined on the closed interval, the A and B. Think about the picture that we just saw. And let delta be a partition of AB. Remember the delta X that we had? All right, given by A to B. So each one is what? My rectangle. This is x1, x2, x3, x4, da, da, da. Are you with me? That's what that means here. That's my lower bound, that's my what? Upper bound. Okay. Well, delta x is what? Width. Are you with me? The width. And then CI is any point in I subdivision, sub-intervals. So you can write it like this. This is what we wrote down, remember? This is how you use to find what? Area under the curve. This is the same definition. They use C, I use X. That's the only difference. All right, everybody wake up. I know this weather is kind of like this, and I know I'm talking about theories. Everybody wake up. This is something that you can use. All right? Now I'm going to talk about the new terminology called norm. Norm is like absolute value, okay? You use double bar, all right? Norm of the partition is denoted by this. The width of largest subinterval partition delta is the norm of the partition is denoted by delta is double bar. Delta, okay? This double bar is that called what? Norm. Okay, it's always positive, okay, or zero or positive. Well, let's look at it. So don't worry about this. Now, definite intervals. So now, definite interval is introduced to you using a Riemann sum, in other words. So remember this. I'm gonna make my delta x to goes to what? My delta, the width, to goes to where? Zero. That same means I practically have what? No width. All right? Almost like a sticks. I'm putting a sticks line up to what? Fill up the area under the curve. Is everybody with me? Okay. So that case, when you do this, you get this number. The L is your area under the curve. And they're using a definition of a limit to figure out what L is, what your limit is, and what your absolute value is. Don't worry about it. I'm not gonna go through this, but just understand this. I'm using a Riemann sums to derive what? Definite intervals. So I'm not gonna ask you to prove this, so don't worry about it, but I want you to understand this. The concept is this. By the way, this is very important for the computer science majors. Listen carefully, because computer science majors, you will have a problem that's a continuous problem. Okay, you will have a continuous problem, but you cannot program continuous program. So you have to make that into discrete problem. That's what using a Riemann sum. You're not gonna do interval, but you have to use Riemann sum to calculate something. Because a computer cannot find continuous things. Computer has to make starting number, ending number. So you have to make it to be discrete. This is what they're doing. But if you have so many of them, that's almost like what? Continuous. So you can break it into continuous problem into what? Discrete problem. Is everybody with me? This is very important for the computer science majors and math majors. When you do go to upper level, you have to know how to change from discrete problem to a continuous problem and continuous problem to discrete problem. This is what it is. This is a discrete. Does everybody understand? This is a discrete. Hey class, what discrete means? It's like a natural number, it's chopped. Discrete means you can count. All right, you can count this of them. How many? It goes up to n of them. It could be 10, it could be 20, it could be 1,000. You can count those. This is what? Continuous problem. What continuous means? You cannot count. Are you following me? Have you taken probability and statistics class?
No.
There's a continuous one, there's a discrete ones. Remember that? You don't remember? Okay, but anyway. So, they give you very important information here, definition here. Hey, I can make discrete problem, which is countable, to what? Continuous problem, which is not countable. This is what? Measure. You have to measure this. This one you can count. This is what? You can measure this. That's the difference. Continuous means you measure those. Count means what? Something that you can count. Like I have 7 apples. Those are count. This is countable. This is what? You have to measure. You gotta get the tape measures and measure it. All right? Do you see the difference between discrete and continuous? Okay. So, but now we learn that I can make discrete problem into continuous if I have what? My width to be what? So small. Then they're what? They're equivalent. A and B. All right, so let's do the real problem then. But everybody understand the concept now? I'm using a Riemann sum to make it into what? Continuous problem using calculus to figure out things. Because doing this way is too hard, too much work. You gotta have a computer to do it. This you can do by hand by using a calculus. Do you understand? This you need a computer. This you can do by your hand by using a calculus. All right, this problem. Now, before, if I want to do this problem, I have to do, if I use Riemann sum, if I want the Riemann sum, what do I need to do? 2x is this. Okay, and then it says -2 to 1, and this is what I'm going to find area. This is the area I wanted. Are you with me, class? And then I have to make a rectangle. And I'm going to say n equal to say 4, then I got to make 4 rectangles. That's how I need to create it. It's so much work. Do you understand? But now I'm not going to do this way. I'm going to use calculus. So this is how you're going to do. So if I want to find this is what you have to do. Is everybody with me? I'm going to do opposite way, right? But 2 doesn't matter. 2 is just a number. I can rewrite it. Is everybody with me? What do you do? What do we do about the antiderivative? What do we learn? So I have a 2, and then what am I going to do? You got an x, now you're going to do what? Add 1, and then what do? Divide 1, right? And used to, I have to put plus c. Am I right, class? Now I'm not going to put plus c because they told me where to what? Evaluate. I'm evaluating between which 2 number? So I'm going to do my lower limit is what? -2. My upper limit is what? 1. That's what that means. Are you with me, class? So this is what that means. Let's finish it. So this is the same as 2 over 2 and x to the square and -2 to 1. Is everybody with me? 1 plus 1 gives me 2, right, class? Are you with me? And 2 and 2 cancel out, so actually I only have a what? X squared evaluating from x to what? I'm just going to put x. Is everybody with me? X is a -2 and x is what? 1. So 1, you plug in 1 here. Are you following me, class? Watch me. Upper limit minus what? Lower limit. That's what I'm doing. So I will do 1 squared minus what? -2 squared. So listen, this is your new. We haven't done this. So whenever you have lower limit to upper limit, you do like this. upper limit, plug in upper limit, minus what? Lower limit. So simply this is equal to what? 1 minus 4, which is equal to what? -3. So I cannot talk about this as an area because there's no such thing as negative area. All right, but you're gonna say this means you have a what? There's stuff under the what? X-axis, which means this is bigger than which one? That part. That part right here is only what? 1. This part over here is how many? 4. So you have a more stuff under the x-axis than a y-axis, above the x-axis. So there's more stuff than a what? Above x-axis. That's why you have a negative number. This is a 4, this is what? Only 1. That's what that means. Are you following me, class? Okay. So only thing you just learned is what? I know how to take antiderivative, which is right here. In lesson 1, I didn't evaluate. Now I can evaluate because it's definite interval. Definite means they gave you lower limit and they give you an upper limit. Are you following me, class? Okay. Should I erase now? Everybody good? I'm not gonna use summation to do it, because summation takes forever. I'm gonna just do definite intervals. Okay, this is what they're saying. There's more under the x-axis than a what? Above x-axis. So that's why you have a -3. All right, because definite interval in example 2 is negative, it does not represent the area of a reason. Okay, we don't say area because area has to be what? The 0 or positive number, just like a distance. Distance has to be the 0 or positive number, so I'm not gonna call it area. But definite interval, which we just did, can be what? Positive, negative, or what? 0. In our case, we had a what? Negative, which means you have more stuff under the x-axis than above. There's more stuff happening here. But definite interval, to be interpreted as an area, the function f must be continuous and non-negative on A and B, as stated in the next theorems. The definite interval as area of a region, f is continuous and non-negative on the closed interval, then the area of the region bounded by a graph of f, x-axis, and vertical line, x equal to A and x equal to B is given like this. That case, you can say area. If it's everything above x-axis, we call it area. If you're under the x-axis, we cannot call it area because you get a negative number. All right? All right. This is area. Everybody see that? It's everything above what? X-axis. I will call it area under the curve. All right, let's do this one. Each person do this one. Let's do A and B. And then C, let's do it together. Okay, A and B, you can use definite interval if you want to, or you can use geometric formula. So this is what it looks like this. I will draw a graph. This is what it looks like. Do you know how to find the area of that? So if you don't want to use interval, can I find the area of this? What's my area? Or somebody tell me. Don't even use calculus. Can you tell me the area of this? 12. How did you do that? This is a 3. This is what? 4. So my area is equal to what? 3 times 4, which is what? 12. So this kind of problem, I don't even have to use calculus. I can do it. But can I use calculus to also verify that? Okay, let's verify that. We know this is a 12. Is everybody with me? but let's verify with the calculus too. So this means, so I don't have any of them, so I'll put it what? X to 1 divided by 1. Remember, I can rewrite this one as this. I want you to see this. Can I write it like this? Is 4 same as 4 times x to the 0 power? I'm asking you, is that true?
Yes.
Yes, because anything to 0 power is what? 1. So this is actually just times what? 4 times 1, which is same as what? 4. But if I put the 0 there, then you know what to do because you have this formula. What does the formula says? Add 1, and then what? Divided by the power. So that's what I did. 0 plus 1, which is 1, and divided by 1. Are you following me, class? Okay. So, and everything, our evaluate from x equal to 1 to what? X equal to 3. So that really just means 4x so let's plug it in then. 4 times 3 minus what? 4 times 1. My answer is not correct. It's supposed to be 8. What did I not do right? This one says, oh, class, I got it wrong. Why did I get it wrong? My picture is wrong. Class, tell me, what is my picture wrong?
3 and a 1.
My picture should start at where, class?
1.
1, not 3, right? So my picture should be where? This my picture should be. Am I right, class? So my width should be not 3, but what's my width? 2. You see that? If I didn't do my calculus, my picture is wrong, I wouldn't even know. You guys, are you with me, class?
Yeah.
I just correct myself because I checked my work using what? Calculus. So I'm going to say, okay, my picture is incorrect because it says my limit supposed to start at where? 1 to 3, not 0 to 3. So it should be 2 times 4, which is what? 8. Let me draw my picture better because I don't want to have an incorrect picture. So the area that I am interested in is what? 1 to 3, and then what? Go all the way to 4. This is what I'm interested in, which is area is equal to what? 2 times 4, which is 8. And then we proved it right here, 8. Is everybody with me? So far, so good? All right, I don't have to do the other 2 because I'm going to show you this using integrals. But do you want to do this one geometrically and do the integral way? Okay, how about this one then? Let it be. All right, first thing first, let's draw a picture right. This is 0 to 3. 1, 2, 3. It says, I'm plugging 0 to be 2. And 2 to be 5. All right, what's my graph looks like, class? When you plug it in 0, how graph looks like? X plus 2 graph looks like what? Starts at 2 and then goes where? Up. Like that. Only part that I am interested in is only what? Yes? That's what I am interested in. What shape is that, class? What shape is this geometry? It's called what? Trapezoid? Trapezoid? Okay, how do you find area of a trapezoid? Good thing you know your calculus. Because if I ask you to do this using geometry, you may not know how to do it because you don't remember all your figures. Okay, you don't remember how to find the area of different figures. So this is a trapezoid. How do you find the area of a trapezoid? Anybody remember? Area of a trapezoid is what? 1/2 times what? A plus B times what? Height. So A and B is what? Base 1, base 2. Are you with me, class? Okay. So I'm not gonna call that to be base because they're not straight lines. I'll probably use this one to be my base 1, that to be my base 2. All right, what is my base 1 height? 2? What's my base 2 height? 5. What is my height? So I will call it this to be my height, that to be my height. What's my height? 3. So my area would be then what? 1/2 times 2 plus 5 times 3 times 3. What's that equal to? 20 over 2? All right, that's one way. Can I do another way using an integral calculus? Let's do the calculus way. So which means I have 2 of them. Right? Or I can do together, whichever you want to. How about we just do together? Because you know how to do it. I think you know how to do what together. All right, can you work together at the same time? So x, tell me what's that equal to then? X become a 2 divided by what? 2? What about this 2? 2 just simply become a what? 2x. Everybody got that? Okay. Now what do? I will evaluate it, starting with x equal to which number? 0, and then to the y, x equal to which number? 3. Are you following me, class? Okay, everybody need to wake up. I feel like I'm talking to the wall. Okay, everybody wake up.
Okay, so why did that become x squared?
This is a 1 power. Remember you do antiderivative, you add power, not
Okay.
subtract power, right? So you add 1 more power, become a what? 2. And you don't multiply, now what do you do? Divide. So you put 2 underneath. Because we're doing antiderivative. We do opposite of whatever the derivative we used to do. So, what's that equal to then? That's equal to then 3 squared divided by 2 plus 2 times what? 3. All right, that's first one. Is everybody with me? And then minus what?
0 squared.
Right, 0 squared divided by 2 plus 2 times what? 0. So this gives me 9 over 2 plus what? 6?
9. That's 9. Again?
Okay, and this one is what? Simply 0. Is everybody with me? 0 divided by 2 is 0. This is a 0. So what? Simply my answer is just what? 9 over 2 plus 6. Remember 2 times 3 is 6. So that's the same as this one. The 6 is the same as what? 12 over 2. Which is same as what? 20 over 2.
Okay.
Same number.